Hi, in this video we will introduce the notion of span of a set of vectors. So let's just dive into it and let me write the definition. So consider we have a set of vectors. So let S, which have a bunch of vectors here, k vector, be a set of vectors in Rn. So in any they will have any number of components you like. So all of them are coming from same Rn. Then put all the linear combinations of these vectors together. So all the set of all linear combinations of vectors in S is called the span of S, or span of V1 up to Vk. And the way we denote it is either span of S, or we denote it as span of, well, V1, V2 up to Vk. And again, this is what? This is all linear combinations of these guys. You put all of them together such that C1 to Ck are scalars. You put all of them together and those will form a set that is called a span of V1 up to Vk. For example, you can now see that this question, what is the meaning of this question, is 1 to -1 in span of these two vectors, 2, 1, 0 and -1, 0, 1. So this is the question that one can rephrase it and ask that, is 1 to -1 a linear combination of these vectors 2, 1, 0 and -1, 0, 1. So that's other way of asking this question. And remember, how do we check this thing? Yes, you form this matrix, augmented matrix, 2, 1, 0, -1, 0, 1, and then put the vector v on the right hand side, 1, 2, -1. Try to solve this guy here, so I can make this 0 by doing this operation. So I multiply the first row by 1 over 2 and subtract it from row 2. So this will be 0, this will be 1 over 2, and this will be, what, 2 minus 1 over 2, this is 3 over 2. And everything else stay the same. Now, well, let me just multiply the whole row 2 by number 2 such that I get nicer numbers here, and then use that number to make to make this guy 0 so that we get to row echelon form. So this is row 3 minus row 2, which gives us 0, 1, 3, and this will give us 0, 0, and here is the thing. Negative 1 minus 3 is negative 4. And you see right away that, okay, this is inconsistent. That means that there's no way that we can write this guy as linear combinations of these two vectors. So it is not a linear combination. That means that, well, the vector is not in the linear combinations of these guys. Or for example, we have done this example a lot. That example, the 0 vector is in the span of any set of vectors. Because why? Because you can write 0 vector as trivial a linear combination of any set of vectors given. You just multiply all the vectors by 0, and that's that means that, well, 0 can be written as linear combinations, and it means that 0 is always in the span of the vectors. Or well, we can also sometimes determine the whole span, the set of all linear combinations, the span of the vectors. So the example would be R3 is actually span of the vectors E1, E2, and E3. Remember what were E1, E2, E3? E1 is 1, 0, 0. E2 is 0, 1, 0. And E3 is 0, 0, 1. Why? Because every vector here, you can write it as linear combination xe1, ye2, and ze3 of these three vectors. So it means that every vector in R3 is in the span, and the span of set of vectors from R3 always will generate part of R3. So this notion, we need to do a little bit more examples. I will do another video with some examples of determining the span of given vectors.